Alright guys, welcome back. So in the previous video, we just looked over the basic syntax of fork and worked with its return types in the creation of parent and child processes. And in this video, we are going to see multiple forking. So first of all, let me just execute this program, which was made in the first video. Let's compile it again and then execute it. So you can see that 2 hello world has been printed because of one was of the parent and one was of the child. And now let me just add the fork here one more time. So now you can see there are 2 consecutive forks. Let me now just save this and execute this. First of all, let's compile it, part2.c, and now let's just execute the file. And you can see there are 4 print statements, that is 4 hello words, this, and this. Let me just execute it one more time by clearing the screen. Let me just, okay, so you can see that there are 4 consecutive hello words. So how that happened? When we were just forking one time, there were only 2, and now we have used fork one more time, and now there are a total of 4. So to understand this, let's just move over the board. So that was what I explained in the previous video of how your parent process is duplicated into parent and child process in my first video when there is only one fork system call invoke. So now we are going to encounter fork after fork, that is multiple fork. And how to deal with that? So let's just put a fork over here, and now let's just say that your program has reached that point. That means it has executed this system call, and now your processes are one is parent and one is child. That means you are having currently 2 processes in the system. And now you see what I told you, that each process is going to have its own address space. So that means whatever there it is after the fork, parent and child are going to run that concurrently. So that means both this parent and both this child are going to execute this fork. And now you know what happens when when you encounter the fork. The one process is duplicated into the parent and child process. Now let's just see what happens. First of all, let's just assume that the parent is picking up the pace, and at that time you have 2 processes in that system, and parent is taking the lead. Now the parent will go and execute this fork, and it will be divided into 2 branches. So let's just assume that after that the parent has terminated, and now it's time for the child. So child will also do the same and divide its branch into 2 after it's encountered the fork. Let me just clearly visualize this for you. That is basically the whole structure when there are 2 multiple forks system call one after another. You see this process has been duplicated into the child process, and the parent process remains the same. And this child process is again duplicated, and this child becomes the parent, which is it remains the same, and another child is created, which I have named it C1. Basically you can also write P or C here. So I just want to clarify that the child process in the parent will remain the same, and this its another child will be this child. And now to just memorize that how many processes are there in the total system, you will just look up at the leaf nodes. You are going to see how many leaf nodes are there. So in this case there are 4 leaf nodes. So that means this system or this program will have 4 processes which will be running concurrently. And now there is a very easy way to memorize this, like what if there are more than 2 system calls of fork, like say there are 3 fork consecutively, or there are 4 forks consecutively. So there is a very easy way to remember this, which is 2 to the power of n, where this n is going to be the number of forks. So for example, in this case we have 2 forks, so 2 to the power of 2 equals to 4. And let's just assume that we have only 1 fork, so 2 to the power of 1 will be 2. So that's just basically the whole idea of how multiple fork works. Okay, so now you have seen the whole idea of basically calling the fork multiple times. Let's just write fork here one more time. So now there are three forks, and you know the formula 2 to the power of n, where n is the number of forks. So 2 to the power of 3 equals to the 8. So that means they are going to have 8 hello world in my program when I'm going to compile it. So let's just first compile it and then clear the screen. Now let's just execute. So you see there are 1, 2, 3, 4, and that's so the 4, 8 total hello words. Let me just clear it again and do the same. See, there are 8 total. So you see there are total of 8 hello words printed on the screen. Now let me just add fork here one more time. So now how many do you think hello words are going to print? Again, 2 to the power of 4 and 16. So let me just save and compile it, part2.c, and clear that, and then execute a.out. You can see there are total of 16. Let me just verify it. See these 4 and these 4, these 4 and these 4. So total of 16 folks, 16 hello words have been printed on this scheme.